In this video, I'm going to prove a few facts regarding modular arithmetic. It goes on to say that if a is an odd integer, when you square a, you'll get 1 modulo 8. If a is any integer, modulo 9, a will be congruent to either 0, 1, or 8. And I think that's going to be a cube. Let me look that up, please. Here. It was supposed to be a cube is congruent to 0, 1, or 8. The third one is for any integer, a cube, that is, the number being cubed, is going to be congruent to that same number, modulo 6. If you like seeing mathematical proofs, or even just reading mathematical theorems and postulates and facts and consequences, subscribe to my channel, as I assure you, any video you click on in my channel will state a theorem or consequence, or maybe both a theorem and some consequences along with the proof, just like we're going to do for 1. It says if a is odd, then a squared is congruent to 1 mod 8. Well, we're doing things in mod 8, so we should think of a either being 8q with no remainder, or a is 8q plus 1, or a is 8q plus 3 plus 2 I left out, plus 8q plus 4, etc. all the way up to a is 8q plus 7. Now, we want a to be odd. So 8q is even, 8q plus 2 is even, 8q plus 4 is even. The only ones that are going to be odd are 8q, which is even, plus 1, or 8q, which is even, plus 3, or 5 and 7. So a will be in the form of 8q plus k, where k is 1, 3, 5, or 7. Let's see if when we mod a squared, do we get 1 mod 8? Well, a squared will be 8q plus k squared for these allowable k's. And just realize that you're always going to get 8 times some integer plus k squared. And this is going to equal to k squared mod 8, because that's 0. So the question is, what's k squared going to be, and what is it equal to mod 8? Well, if k is 1, 1 squared is 1, which is 1 mod 8. We're on a roll because that's what it's supposed to equal. If k is 3, then 3 squared, which is 9. Oh, that leaves a remainder of 1 when you divide by 8. So once again, we got 1 mod 8. Now, if k is equal to 5, well, 5 squared is 25. Oh, that's 1 more than a multiple of 8. It's 24 plus 1. That is, the remainder is 1 when you divide by 8. So we keep getting the right type of answer. 1 mod 8. 7 squared is 49, but 6 times 8 is 48. That's 1 more. That's 1 mod 8. So I kept getting the same answer, 1 mod 8. The problem asked me to always get 1 mod 8. We're doing fine. Now we need to look at a cube mod 9. And a can be any integer, not just odd integers. So modulo 9. One moment, please. So in mod 9, a complete residue would be, for mod 9, it would be 9 cubed, 9 cubed plus 1, 9 cubed plus 2, all the way up to 9 cubed plus 8. That is, a will be in the form of 9 cubed plus k, where k is either 0, 1, 2, up to 8. And we want to show that a cube, find out the residue for a cube. Okay. When you cube a, you're going to have this cube plus some other positive, plus some integers, multiples of 9 cubed all squared, plus some integer multiples of 9 cubed. Those all are going to have 9s in them. And then you're going to have k cubed. That is, a cube is going to be in the form of 9 cubed plus k cubed. And this is just going to be k cubed mod 9, because that's 0. Okay, so what can k cubed be? Well, 0 cubed is 0, which is 0 mod 9. 1 cubed is 1, which is 1 mod 9. 2 cubed is 8, which is congruent to 8 mod 9. And we have to go through it. If you know an easier way, turn me on to it. 27, well, that's a multiple of 3, multiple of 9. So that's 0 mod 9. 4 cubed is 64. Well, 7 times 9 is 63. That leaves a remainder of 1. So 4 cubed is congruent to 1 mod 9. 5 cubed is 125. 9 goes into 125. Well, let's see. Don't really care how many times it goes in. I care about the remainder. Now, if we say 9 goes into 35 4 times, then the remainder is -1. But a remainder of -1 is the same as a remainder of 8. Now, I could have said it goes in 3 times, take away 27, get a remainder of 8. Now, 6 cubed, well, that's 6 times 6 times 6 divided by 9. Well, that's 36 here. 9 goes into 36 4 times. So 9 goes into whatever 6 cubed is, which happens to be 216. It goes in 24 times with no remainder. This is 0 mod 9. Now, 7 cubed is 343. How many times does 7 go into 343? Or more important, what's the remainder? 7 goes into 34 4 times. That leaves 6 left over. And 7 goes into 63 evenly. That is, the remainder is 0 mod 9. Okay, now 8 cubed, that's our 256 if I'm not mistaken. It's 64 times 8, so it's actually 512, excuse me. Glad I checked. How many times does 9 go in there? Well, it goes into 51 5 times, that's 45, with 6 as a remainder. And 9 times 7 is 63. From 69 leaves a remainder of 6. Which, of course, I have a problem. Well, first my problem is I'm pretty sure I said 64 times 8 is 512. And I at least better say an even number, because 64 is even, 8 is even, their product is gonna be even. Okay, so 9 goes into 51 5 times with 6 left over, and 9 almost goes into 62. It's 1 short. That means that the remainder will be 1 less than 9. It's gonna be 8. If you don't believe that, 9 goes into our 62 6 times. 62 minus 54 is the remainder. Okay, now these are all the answers. I have 0 mod 9. I have 1 mod 9. I have 8 mod 9. 0 I already said. 1 I already have. 8 I already have. 8, 0, 0, and 9. And 8 I already have. So what we have is that 8 cubed is congruent to 0, 1, or 8 mod 9. And if we look up here, that's exactly what we were supposed to show. A cubed mod 9 is 0, 1, or 8. Now, I want to show that for any integer, a cubed is congruent to a mod 6. I want to show a cubed is congruent to a mod 6, where a is any integer. Okay, so mod 6, of course. So a is either 6q or 6q plus 1, 6q plus 2, all the way up to 6q plus 5. So we'll say a is 6q plus k, where k is equal to 0, 1, 2, 3, 4, or 5. So now a cubed, just start catching on. All the terms of 6q plus k will be a multiple of 6, except that last term, which will be k cubed. Now, k can either be one of those numbers. Well, if k is 0, 0 cubed is 0 mod 6, and what? Or 1 cubed is 1, which is 1 mod 6. 2 cubed is 8, which is 2 mod 6. 3 cubed is 27. That's 6 times 4 plus 3. That's the remainder, mod 6. 4 cubed is 64. Well, 6 goes into 64 some number of times with 4 left over. 6 times 6 times 10 is 60 plus 4 more. Now 5 cubed is 125. Well, 6 goes into 120. 6 times 20 is 120 plus 5 more. So the remainder is 5 mod 6. 0 cubed is 0, 1 cubed is 1, 2 cubed is 2 mod 6, 3 cubed is 3 mod 6. So basically we got that 6 cubed plus k is congruent to 6 cubed plus k. That is, this cube is congruent to itself. No matter what k was, we got k back. Mod 6. Why am I adding 6 cubed? For 2 reasons I'm adding 6 cubed. The most important reason is it's 0, so I can add it. And I want it to look like this. That is, if I call what's in the bracket A, then I'm getting back A mod 6. No matter what k was. Okay, in other words, just one quick example. If 6 cubed, if it was in the form of 6 cubed plus 3, I did get back 6 cubed plus 3. That is, the remainder, when you FOIL this out and divide by 6, the remainder will be 3. But I don't want to get back 3. I showed over here why the remainder will be 3. But I don't want to get 3 back. I don't want to get that back. I want to get this back. So I add 0. 6 cubed plus 5 cubed. Yes, 100%. It equals to 5 mod 6. But you know what? 5 mod 6 is congruent to any multiple of 6 plus 5 mod 6. And why did I pick that representative of a multiple of 6? Why didn't I say 6m or 6f or 6t? Because I wanted it to look like 6 cubed. Okay, so yep, the theorem follows from, well, the theorem really follows from here. That is, that's what we set out to show. Okay, whatever a is, if you cube it, you get back a mod 6. And this is because we showed over here, so maybe this wasn't enough. It was 90% enough. We showed that 6 cubed plus k cubed is congruent to k mod 6. But as I mentioned a moment ago, that's the same as 6 cubed plus k mod 6. I just said it more formally. That is, if you cube this number, mod 6, you get back the same number. That is, a cube is congruent to a mod 6 for any integer. The proof ends right there. As always, if you like watching mathematical proofs, you should subscribe to my channel, as this is all I do on this channel. I do mathematical proofs. Leave a comment, subscribe to my channel, click the like button. See you guys in the next video. As always, watch and learn.